Hi, how are you? How are you doing? Welcome back to EUM 114 Advanced Engineering Calculus, Vector Calculus. How are you? I hope that all of you are in a good condition. And today I'm going to cover and I'm going to continue with what we have done so far. Surface integral, and surface integral, as you all know, is one of the very powerful topic that as we have seen before, and as a continuation from the previous lesson, I would like to continue to give you some more examples to give you some clarity in the surface integral. Okay, now let me go through the second example with you. Since we have done the first example and a very lengthy example, today I am going to give you the second example with a different polygon. Okay, today still we are under the topic of surface integral. Okay, surface integral, remember that's okay, that's can I make it a little bit bigger? Okay, hope that all of you can see that. Okay, surface integral. Okay, second example, let f to be the goes to be a 2k. Sorry, this is not a z x y z k, and exists over the surface S defined by 2x 2y z equals to 2, bounded by x greater than 0, y greater than 0, z greater than 0. It's in the first octant. Okay, this is the question. Okay, how to sketch? The first question is how to sketch the polygon. Okay, if you can't sketch the polygon, it's very difficult for you to proceed to answer the solution. Okay, you are required to find surface integral for this question. Exists over bounded by this in the first octant. Therefore, we're going to find the f and the s. Okay, how do we find this? Okay, how to find the surface integral of this question? The first challenge is to sketch the polygon. Okay, can you guess what is this? Okay, go to this. Don't touch force. Force, we never use force to sketch. Goes is not a surface. Remember that. Goes is a force. Okay, therefore don't go and disturb that. You need to sketch your sketching based on this diagram. Is it possible? Okay, what is that? This is tetrahedron. Okay, how to sketch that? Okay, you can sketch this step by step. First, look at this. 2x plus 2y equals to z equals to 2. Let z 0, okay, y 0, therefore x equals to 1. Okay, let okay, z 0, x 0, y equals to 1. Let x 0, y 0, z is 2. Okay, can I sketch this? Of course can. Okay, can you follow? That's very simple. You can see the sketch will be like this. Okay, now you see 0 0 1. Okay, let's say this is a z, this is a x-axis, this is a y-axis. Therefore, at the x point of view, we can say 1 0 0. Okay, this one here we can get a z, therefore we get a 0 0 2. What about this? This is basically y-axis, this is a 0 1 0. Therefore when you start sketch, this is a straight line. Very simple, very simple. Why is become a straight line? The first question. Okay, make it z as 0. And see, can you see this? This is a straight line. Okay, make it anything, one of this. Okay, x 0. Then you can see this is a straight line. Okay, therefore it's supposed to be straight line. You cannot say, oh, it must be a y. It should be a. It's a linear graph. Therefore, when you start sketch this, you will get a kind of tetrahedron. Okay, okay. With that, okay. Now we know there is a ghost going inside here. Okay, we know there is a ghost going inside. The ghost basically is xi, yj to zk. Okay, now sometime the question they would like to say which surface. Okay, question might be different. You must read the question carefully. Are they wanted to solve the whole surfaces? Okay, here we have how many surfaces? 4. A, B, O, C. We have altogether, we have a few, you can see O, maybe I'll say surface 1, A, B, O, maybe O, A, B, whatever. Okay, as long as you can understand this is enough. It's a surface 1. I call it surface 2. OAC, OAC, S3, OBC, OBC. Okay, surface for this. Okay, surface for ABC. Okay, okay. The challenge is how do we able to start, or basically we can start with the any surfaces, no problem. But sometime that what I wanted to emphasize here, okay, sometime the question they may say particular surface only. They will say, maybe they may say, okay, find out ABC alone. If they mention that, don't try to go and find out all the other surfaces. Okay, depends on the question. If the question asks you the whole, don't. If they didn't mention anything about the particular surface, or they didn't highlight the, if they will say, okay, find the surface integral for ABC alone. Okay, that means you need to go and find out only this. Okay, but if the question didn't say anything, then it's of course by default you need to find out all the surfaces. Okay, now let me start with the simple surface here. Okay, let me start with the OAB. Okay, OAB first. Okay, how to find out OAB? That means I need to find out S1. Can you see that? Okay, you are required to find out OAB. Okay, in the OAB, first you see this is the surface that we are referring to. Okay, we are referring to this surface. Okay, therefore we are not going to see the internal part of that. We need to find F is known. F is known. This is the ghost is known. Okay, our first task is what is N. Okay, what is N? And yeah, I need to emphasize here also. Some student did ask me why end is a changing, that n is a normal, okay, normal to the surface. Okay, by this normal surface calculation is different from the normal unit that we learn in the vector. Remember, this is a surface integral. Okay, this is a surface integral. We are trying to find out the surface integral normal to the surface integral. It's not a, we are trying to identify the unit vector. The unit vector basically for the vector line integral is a different, slightly different, the way that we are trying to find out the solution. Okay, the most important things that I want you all to understand is we are trying to find out surface normal integral. Okay, now if this is the case, we know the n is pointing out. Okay, why? This is negative k. Why negative k? Okay, we don't go inside the polygon. Okay, we are trying to see where the surfaces that it's having contact point with the external world. Okay, we are interested how the contact point with the external world. We are not interested, moving inside the box. Okay, the contact point outside of this AOB outside of this is here negative k. Okay, then at this particular point z is a 0. Okay, can I now combine f dot n here? Can, right? This is xi plus yj plus zk dot product with this negative k. Then solve the solution, we get a negative z, and since z is a 0, it's a 0 overall. Wow. Yeah, that means no impact. That means when I touch this surface with this ghost, the ghost never react to me. The ghost in this case has no reaction power on this surface. Okay, that's a message that you got it here. Okay, what about A, O, C? We no need to find out again. You see, am I need to further calculate this? No need. Actually, it's very well understood and well established. We no need to go for the ds. We no need to find out the ds at all. Okay, because since this is a 0, of course the whole thing 0. Therefore, don't ask me why, sir, what is this answer? No, actually answer is 0. Okay, no need to calculate here. Okay, what about S2? Okay, S2 is a OAC. OAC. Okay, in this case, OAC, OAC. Where is the contact point, external contact point? Outside, right? It's a pointing towards outside, right? Therefore, the end here is negative j. What about y? At this point, y is a 0. Okay? Can I find out this? F dot with the n? Wow, this is easy also, similar to this. But here you put a negative j, you get a negative y. Which is, since in this case is a 0 as well. Oh, okay, it's look like everything 0. Are you? That means this ghost is not a good very powerful ghost. It's no impact to many point. When you touch this surface also, the ghost never react. Okay, you touch this surface, ghost never react. What about this surface? Can we calculate and see? This ghost is a very good one. It's not reacting for many surfaces here. What about S3, which is OBC? Is it okay? Let's say we try with that again. OBC pointing towards this, which is x negative here, and it's a negative I. Same seems. Okay, x equals to 0, fn okay, negative x equals to 0. Wow. That means, is it going to be all the answers going to be 0? No, cannot. If there is a ghost, definitely very rare, cases that you will end up 0. Okay, but I don't want to comment anything at this moment. Okay, let us follow the mathematics. That's it. Okay, we no need to conclude. We no need to specifically decide. That's become a big blunder when we presume. We start presume, then it sometime it may be wrong. But let's follow the mathematics. Let the mathematics guide us. Okay. Therefore, in this case, we get all the surfaces 0 except this one yet, A, B, C. This is where we begin, the challenge begin. Okay, the challenge is begin. This is not easy to calculate. This is not easy to calculate. Why? Okay, can you imagine, can we use all the surfaces? We can find out n is a smooth. But except A, B, C, the surface is not smooth. Can you understand this? Why? Put it here, for example. It point here. Put it here, for example. The surface will be like this. Okay? When you go down here a bit, it could be like that. Okay? Here could be like that. Wow. The surface is all the way, because it's a little bit slanted. Therefore we cannot immediately conclude, oh, the surface is straight. Cannot. It is not a smooth surface anyway. Okay, therefore how do we going to handle this problem? In order to solve this problem, first we need to use what we call as we need to use ABC, which is S4, and we need to use del F. Some student ask me this question anyway. Sir, why normal unit suddenly change to this form? Some student did ask this question as well. Okay, it's a very good question, but I cannot give you a very lengthy explanation for this. But in a simple term, how can unit gradient suddenly become a unit normal? Which is I don't understand. Some student ask this question. Okay, this is actually I appreciate your curiosity. Okay, as I say, this normal unit vector is not referred to. Remember, it's not referred to the line. Okay, it's not referred to any line. Actually, this is a surface that we are discussing. Okay, that means it's not a one single line, we are talking about. There are many. Can you see this? This is not a one. This is not a one single point that we are talking here. Many. Can you see that? How many? That means it's going to be a many, like that. I don't know how many points it will be. Therefore, how to handle this? Can we use a normal unit vector here? See, many different what we call angle of what we call normal unit. Therefore, can I represent this with every single unit with these things? Impossible. Therefore, we need to use what? Gradient. Okay, gradient. That's a very important. That's why I emphasize to you, gradient play very important role in this case. Okay, how do we handle this part? Okay. In the first, I hope that straight away I'm start writing here del with the del x the whole results. Okay, therefore we know that's I and del f. Wait, f is 2 2 okay 2 2 1 okay f del yj plus del f del z k. Okay, then this one is the f. Okay, then we no need to show this anyway. Next time I won't show this in detail. Okay, for this. Okay, if this is the case, once you place inside, you get a di 2j k. Okay, since 2 4 8 9 4, you get a this square root of 9, where you get a 2i plus 2j plus k divided by 3. Okay, with this we already identify end. Now what about ds? This is the big challenge. Okay, can I use ds actual? Okay, this is you please take note on this portion. You cannot calculate actual surface of this. Okay, we cannot calculate actual surface of this. A, B, C. Okay, triangle. This triangle is a slanted. Okay, it's a slanted. Therefore, you wanted to calculate, it's a very difficult. Okay, you may face a lot of difficulties because you need to calculate straight, you need to, a lot of works to be done. Therefore, one of the easiest method and standard method to solve this tetrahedron slanted position of triangle, you need to use shadow. Standard. We no need to use anything else. Don't think anything else. Just straight away, if you see this question, remember you must use shadow. Okay. Therefore, this I will say, for this particular case, shadow is the best and only best solution. Okay, shadow. You must use shadow. Okay, therefore, when you use shadow, you must use dA. Okay, which is we're going to shadow on some place. Later I will explain to you what we're going to shadow on. Okay. Okay, how many ways do we have to shadow here? Okay, here, where do we able to shadow this? Okay, your question is, okay, I would like to shadow, but where can I shadow? The beautiful thing is, for this particular case is, we can shadow this to the OAC or OBC or OAB. You have a three-way to shadow, and any method, if you choose any option of this, you will get same results. Okay, you should think about this why, but I'll give you all the options will give you the same results. Okay, how do we map? Mapping, I'll show you the mapping model first. The mapping here, since you can see, and this is kind of like that. Okay, A, B, C. Okay, A, B, C, O. Here, when you map, therefore the shadow position here, for example, if you map to this, consider, you cannot change the position, you cannot change the normal unit vector here, this gradient of this. Okay, the surface never change. Therefore, let's say you are choosing AOC as your mapping. Okay, let's say you are mapping of ABC on OAB. Then row, the row here is a K. Here we know this is a Z. This is what just now is a Y, is an X. Okay? When you map it on this, the row is a K. How do I know? OAB, sorry, this one, okay? Okay, this one, okay? That means you are making the shadow onto this. This top one will fall onto this. Remember, I show you this. Let's say this is the paper, this is the shadow, this is the normal vector, which is a various angle, with a various angle, that I go and make it fall onto this, fall. Okay, fall on the ABC, okay, OAB surface. And do you think the things never change, right? Therefore, you must follow the Z, okay, is fall onto this surface. Mapping, you know, we are mapping. Therefore, the arrow here never change, but it go and fall onto this OAB. Okay, therefore when make it, let's say this is a kind of a paper like this, okay, let's say this paper is high, like, you know, I make it this fall on this paper here. Do you think this arrow here initially like that and it fall here, it change the position? No, but it all the surface will be straight, smooth, and it refer to K. Okay, therefore the row become K, and N times with the row, okay, when you times N to the K, can you see this? 2I, oh, you cannot see, 2I 2J plus K over 3, dot product with the K, we get a 1 over 3. Is it okay? Okay, again, option. This is option, we are looking at the option 1. Okay, option 2, you can mapping of ABC on OAC, okay, OAC, if row become what? Can you guess? OAC, OAC. If you go and put it here inside, what do you get? It refer to Y. Y is a J. And with the J, you will get 2 over 3. What about option number 3? You don't need to do all the option. I'm showing only. This is option. Option, remember. You don't need to do all. ABC on OBC row. If you map it to this side, you get a I. You get a 2 over 3. Okay? You can choose any one of this, place it here. Okay, because this is the actual that you're going to refer. Therefore, the first one, your calculations will be, for example, if I map it this DS DA, for example, case option 1, if I choose option 1 here, the DA is I'm referring to the K, right? Then my reference is DY DX, and DY DX DY, whatever, still N row is a 1 over 3. Okay, this is actually N2 row here, which will give us DX DY 1 over 3. Okay, for OAB mapping. Similarly, You can don't calculate for all. I'm teaching, therefore try to understand. This is option 1 from op 1, op 2. Okay, for the op 2, option 1, option 2. Okay, for the option 1, option 2. What is the option 2? Just this is for the purpose of your understanding. I'm teaching dj. Row J, which is OAC. OAC. That means this will be D X D Z. Divide by hand row. If you mapping on that, it's a 2/3 for what? OAC mapping. Okay, you can choose any one of this. Okay, I'm showing this option 3 DS. Sorry, excuse me. Okay. Oh, later. Some settle. Okay, something to be adjusted here. Okay. Okay, sorry. Okay, now DS for this here. Okay, for the option number OBC. OBC. What is it? OBC. Mapping here. DY DZ. DY DZ. Okay, 2/3 for OBC mapping. Okay, now I'm going to show you how to calculate this. Okay, let us choose any one of this option, no problem. Okay, you can choose any option. Okay, let me choose option 1 to calculate. Can I proceed? Can or not? Okay, copy ready. Okay, now you go. Now F dot product to the DS, and we know Fn is known. Okay, 2x plus 3y over 3z3. Okay, can or not? Do you get me or not? Why is it changing like that? Okay, now let me put it to you. F is basically xi yj zk, right? Okay, when I start working on the n here, f dot n means here xi yj zk dot product with end. What is my end anyway? And n I calculated as 2i 2j plus k. What is that? Oh, I have done this right. 9. No, it's a 3. It's a 3. We know it's a 3. Okay, now if the case is, then we start solving this 2/3, then you get this. Okay, you get this whole thing. Can you see that? Okay. Okay, I hope that you can follow this. Okay, now we're going to combine together ds and this thing. Since we know the ds is that we're going to use here is I choose option 1. You don't need to mention anything, just follow only, because as long as you can give the clarity, I can say dx dy okay, is a 1/3. That means it's a 1/3, right? That means it's a 3 dx dy. That's it. Just go and insert inside. That means you can get this 2x3 3y3 plus z3 3 dx dy. Okay, the big challenge here is what is z. Okay, what is z here? We know x. There is this one is reference to the x and y, but not the z. Z is a big challenge here. Okay, the big challenge will be z. Okay, when you get this, then automatically all the three will be moved, but z, except z will be the troublemaker here. Okay, now okay, can we change the z? Can, because we know 2x plus 2y plus z is equals to 2, right? Okay, can we make z as a 2 minus 2x minus 2y? Can. Okay, cut. Then we place this inside. As I haven't started yet, just let me settle with this. 2x 3y, okay, plus z is a 2 minus 2x minus 2y dx dy. Okay, then disappear. Then the n is 2 z. Where am I made mistakes here? Z. Yes, substitute to x. Okay, this one will disappear and y plus the 2. Suppose we can get this definition by am I made any mistakes here? I think where am I get a 3 here? This one 3 here. Something wrong here. Sorry. This one, how can I get a 3? Just go back please. Sorry, go back. Let me check back again. What is my this is f x y z 2 there is some mistakes here. Okay, yes, 2 f, that's why here when you put here see, f and it's a 2x 2y. It's a 2, supposed to be 2. Okay, this supposed to be 2. Yeah, then only it's correct. Okay, sorry. Okay, now when we remove this, we will get this. Okay, 2 dx dy. Okay, now can we solve this? Okay, now find out dx dy. Okay, here we need to find out y, which is the highest, and the z. Okay, how to find out this? I go back to the first paper here. Look at this one. Okay, we are interested here, this surface and this surface here. Okay, what is this line here? This line is 2x plus 2y equals to 2. Can you see this? This line here, because z is a 0. Okay, at this point here, this is very important. This is very important to know. Okay, how to calculate here. Therefore, the z in this case, let me draw, no problem here, no harm for you to know this. Okay, when I sketch the whole thing first. Again, it's again a repetition. I know it's not good to see all this again. Okay, A. Wait, let me follow A, B, C. Okay, 0, 0, 2, 0, 1, 0, 1, 0, 0, Okay, now in this particular case, you must remember we are using 2x plus 2y plus z equals to 2, right? I wanted to find out this line alone. If a z at this particular point here, when z is a 0, I get this 2x plus 2y equals to 2. Therefore, x plus y equals to 1. Can you see that? Huh? Okay, this one. Here, this line is x equals to 1. This line. Okay? You can verify also. You can verify. You use this 2 point here. Check and see. You get this. Okay? You can use anything else also. Now, if this is the y, the case that you are referring to as you are placing your eye here to the dy, for example, is a y, this is x. Okay, you can choose any one of this method to solve it, no problem, as long as you can work on this. Okay, now here I'm placing at the y-axis. Okay, if I place the y-axis here, this is the standard, my eye I'm placing here. Okay, to see this. Okay, 1, 0, that means it's a 1 higher 0. What about x? Okay, what about x inside? X here, x is a changing. Okay, x is, I cannot say 1, 0 again. If I say 1, 0, it will end up you are finding the rectangle. Okay, you are finding rectangle. You know, x is changing, you know. When I move up, when y move up, the y-x also changing here. Therefore, you cannot use this. Therefore, you need to use this one. Y equals to, in this case, it's x equals to 1 minus y. Here, x equals to y minus 1 and 0. That means again, you can calculate 1 y equals to